Well, hi, good morning. Thank you so much for joining me in my shop here. Today is the 3rd day of May. Cloudy, maybe rainy today. Yesterday was beautiful here. Not so much today. So, what about the radio now? So, yesterday I took the time to replace the power supply filter capacitors. And it was a bit of a long shot for solving the problem in this radio, and it hasn't solved the problem, but it's eliminated the capacitor as a possibility, or capacitors. So low B plus on the output tube, and I don't know if it's low all the way through the radio. The bulk of the radio operates. It looks to me like it's just the output tube alone that has no B plus. So we're going to look into that specific question today. Why is the B plus low on the output tube? If it's low throughout the radio, it'll be the same reason, and we'll probably find it. So I think the place to start is to have a look at the circuitry around the output tube and try to imagine what part could cause the kind of problem that's in here. The B plus should be 110, something in that range. And on the output tube, it's, if I remember right, it was 35, which is ridiculously low, and probably explains why the radio is so silent. So let's take a look at the schematic here. When I was reading the notes on the schematic here, I didn't actually look at the schematic overall, and this is probably a combination of a number of pages put together onto this page. And one of the things is this chart here. This is showing all the voltages. I'll just zoom in here. It's showing all the voltages that are on the tube pins. So this is a great source to check. And one of the things that's interesting is right on the rectifier, it's showing you the maximum voltage in the radio, 105 volts. So by the time we get over here to the output tube, the plate is seeing only 100 volts. But in my case, it's 35 volts. It's way off. Okay, so I have this information I can make use of, but let's just go and take a look at the output tube circuitry here and ask ourselves, how come this plate can have a low voltage? This could be shorted. I would think it would get hot, but this is possible as a cause. And wow, there's not much else here. Oh my, there's next to nothing here. So I have checked, no, this resistor doesn't exist. Field coil is around 600 ohms, I believe, by my measurement, if I remember right. And this resistor measures at 90 ohms, and this resistor measures at 58 ohms. So I don't think these two resistors are in any way responsible. Even though these well, I don't know, I was going to say these are likely a problem, but I won't say that. This is the guy who would usually knock the voltage down in a radio. And look at how they've kind of shown this in a weird way. The first capacitor is actually this one. And this is the second capacitor here. And then this guy, hey, where's he getting the voltage from? 15 and 150, 15. I put a 40 in here. Well, probably only needs 15. What's just, how's it getting its voltage though? Oh boy. From here through that. So that this is filtering way out here. Screens. It's a screen filter or decoupler. I've also changed this capacitor too. And like I say, I put a 50 in here. Not realizing. I just, but glancing at this, I just thought these three are, right in a row, so to speak. Huh. Well, I don't think it's any consequence, really. Too big a capacitor on the screen. I don't think that's the case. I think they're just saving money because they didn't need a 50. You know, put a smaller capacitor. I mean, this is all three of these are bound together. Okay. Well, then what could possibly? Well, you know, output transformer. Now I've checked the field coil. Did I actually check the output transformer? I don't know. Oh my gosh, I remember saying something about it a few videos ago, but maybe I didn't really check this properly. Maybe that's really the starting point. What is the output transformer primary resistance? And that's easy to do because it's the top of either one of these capacitors, and they've got the resistor in between, so it's easy to note, to realize which one of these to do. Yeah, let's do that right away. Resistance of the output transformer. Okay, should not be a problem reading this resistance in the circuit because the far side of the coil is just going to a plate in a tube. It's not going anywhere. Okay, here we go. It's these two wires here. 160 ohms. Let's try it again. $164 ohms. Oh, you can't see it. Wow. One more time, just so you can see the number 2. There it is. 164. Whew. I was thinking about this just a moment ago. I thought, oh man, if this is true, if it's open, I should have found that much earlier on. Not open. Primary not open. Well, there's this capacitor sitting right here. This has got to be the other component, which would, let's just check across it here. Checking a capacitor with an ohmmeter, not the best. Well, how about an ohmmeter that's turned on and maybe in view? I mean, this would have to be really a show. Why so slow? Maybe I must be I'm charging up a big capacitor at the same time. Thought I was. Zero. So I'm trying to go across this capacitor here. Of course, if it's 0, 0, if it's a real 0, then it won't dissipate heat. Wow. Okay. Looks like a 0. Now I've got this up on too high a setting. Let's try it again. I don't know. You can't have it on too high a setting, can you? 0. Well, I think I found a problem here. Okay, I'm going to cut one leg off from the green wire. 0 on a capacitor. That would be a bad thing for a capacitor to show a 0. Just getting a clip lead here because I have a way of forgetting things. That would explain, might explain why this resistor is cooked up a bit. I'll nip this right off. You little bad actor. Let's test it again. Huh. Bad guy. Very bad guy. Let's test it on one more tester. I'll keep testing it till I get something that shows it's okay. And then I'll go, yeah, it's okay. I finally got what I wanted. Actually, I want it to be bad. I want this to be the problem. It's a resistor, 4 ohms. Doesn't look like a resistor to me. Well, there we are. So the number of times I found a shorted capacitor, very, very few. Very, very few. So nothing about it. Might be a little discolored down at this end. Nothing obvious though. Okay, that capacitor is a 0.015. I believe that's what that says. 0.015. Okay, we'll put one in, and I'll bet you this radio will start working for the first time since it's been here. 0.015. Okay, time to give the radio a chance, another chance. This time, I bet you it's going to work. So, volume down. Band, I think, is on the broadcast band. The antenna is connected, and it's actually switched on. We still have the voltmeter at the ready. If I want to make a check of the plate voltage, it's right here, right there. And if I want to check the B plus generally, I could do it on this spot, do it here. Okay, we're all set here. Let's just have you standing right here. How about that? Get a clear view of the smoke. Okay. Switch is on. Volume's right down. I'll just turn up a little bit. Ooh. It just sounds so scrapey in there. Maybe we're going to find out more stuff is wrong. Here we go. Pilot light has come on over here a little wee bit. We're at 100 volts on the supply. That should be enough. Pilot light's barely on. Let's start looking for voltage here. Oh, never mind that. Here comes a radio. This works like crazy. Where'd it go? So what I think is happening here is I think there's DC trying to run through this capacitor, and as you turn it and the contacts kind of rub a little bit, there's a little bit of a makey breaky thing going on there, and with a little bit of DC flowing through it, it becomes really apparent. The same thing happens with volume controls or other controls. If DC is leaking through them, then as you move the slider, you can get a lot of noise. And it sounds like it's dirty, but it's not really dirty. It's just being highlighted by the fact of this DC flow. But I heard it. I heard it come out of the speaker. You know what? I think it's time for a coffee reward. For that, I got sound coming out of the speaker. A lot of sound coming out. Okay, let's explore the schematic here and see if my theory holds up at all. Now it could be, and my theory is DC going through the capacitor. So what we want to prove first is there is a voltage across the capacitor, the tuning capacitor. So let's find it. 2 to 17, 10 to 172. What? 12 to 430. So this sounds like the tuning capacitor. C7. 10 to 172. That's quite a range too. I mean, the radio's only got 2 sections in its capacitor. So this looks like a trimmer, 3 to 30. So these would be the 2 sections here. This smaller one, 10 to 172, would be the oscillator. So we'll probably find it working its way, yeah, into these coils. Look, it says right there, BC oscillator. And this must be the shortwave oscillator up here. You're switching between them with the switch. And then this side is the probably, looks like it's resonating this coil. Shortwave antenna coil. Well, that's kind of interesting. Does that mean when you're using shortwave, there is no antenna tuning? It's fixed tuning. The shortwave band is broad on this, isn't it? Doesn't it go all the way from somewhere to somewhere? Just 1 second here. I'm bending the pointer once again without knowing it. There. So the idea is DC is somehow getting through here. Now, let's follow this one first. Let me just see what's going on. So this is on the B minus here. Chassis ground. Chassis ground. So this is the B minus here. You know, over here it says power line ground. Yikes. Wow, that could be misinterpreted pretty easy because this non-polarized plug. So, yikes. That's a common wiring insulated from chassis. Going back here, just things catch my eye sometimes. So let's trace up this way. Through the coil, we're coming up here, we're coming around. Oh, it's going all over the place into the switch. It's also coming down this way, going across here. Well, what's that? 250 volts AC. Why did it have that written there? So we're getting. Okay, I'm just getting lost. Is what's happening. As I'm tracing these wires, they're too complicated. If we go this way, looks like there's a dot right there. Well, okay, I'm not really getting too far this way. So let's just look at some capacitors that are in this area. There's one here. There's going to be a bunch of them here, all over the place. Who among these could cause something like what I'm suggesting? How could we tell if it's this side or that side that's doing it, doing the problem? How could we tell that? Why would DC, other than making noise, like the radio worked briefly and then stopped working, why would some DC leaking through here even, or pressing against it, would cause the radio to just go south? How would that happen? Don't quite see it. Okay, so I'm not getting anywhere here thinking about this way. What about looking for the DC? Could we look for it? I put a voltmeter across here, continuing with my theories. Put a voltmeter across here and try and see if there's some DC sitting across it. And then I have to ponder whether that's normal or not. I would say not offhand. Well, we can do that. Sounds like a crazy thing to do. Hey, it's crazy. Let's do that. Okay, I'm going to have you look at my cat here. She's staring. Oh, now I disturbed her. She's looking for mice. This cat has caught, I think, 5 mice in about 8 days. And I caught one. I caught a mouse in my house yesterday. Just come walking in my rec room. And the cat was outside. So mouse inside, cat outside. I don't know how she's caught all these mice. Not in our house. She's caught them in the garage. She caught 4 in the garage, 1 in our house. Or she's just looking everywhere. Where's those mice? Yeah, she's going into a very bright room, in case you're wondering. She's not going into heaven there. Well, yeah, I've never had mice caught around my house this way at all. That's a lot of mice. Okay. All that excitement. I've lost track of what I'm doing here. Okay, we're going to turn this guy on, and then I'm going to check the plates here and the plates here. And then come down, contact there, contact there. What? What do you want? You know what she wants? She wants to go in the garage. That's what it is. Back to the cat. Shadow, do you want to go in the garage? And that's your typical response. No real response that I can read. And my other cat, Peanut, who's no longer with us, I could understand him a lot better. I better go let her in the garage because she thinks a mouse is out there, I'm sure. Okay, major distraction over. Voltmeter set to 150 volts. Wow, if I get that kind of voltage here, that would cause me to pause for a bit. So the grounded plates are the rotating plates. You might think it's the other way around, but it's not. And the other plates are the ones that might be holding a voltage, according to my theory. Come on. What's the problem? There, it just takes a long time. I haven't got enough patience here. I also got a this hum. It sounds like a open grid connection. Okay, watching the voltmeter now. 50 volts full scale. Nothing at all. Nothing at all. 1.5 volts. Ooh. It's a negative voltage there. Okay, so there could be AVC voltage sitting here. Well, I'm on the antenna 1. You can see it there. That's all of a little wee bit of a voltage. It's like 0.1 volts. And on the oscillator side, the tiniest positive voltage there. We're talking a whisper of a voltage there. Is this still crackling? Sure is. Okay, so we're watching the voltage and the crackle at the same time. Seems kind of jumpy to me. I don't know if you saw that or not. Let me go on the terminal here. Okay. jumpy alright. And if we go on the oscillator one, it's the teeniest, tiniest voltage here. You can't even see it. Did not seem to be jumping, but it's so small I might not have seen the jump. So this supports the idea that there's some DC involved here. Does it? Does it really? Does it? I have to think about that for a little bit. Maybe I'm not even right on that. And I'm going to guess having a little bit of AVC voltage on these plates is normal. Probably if we study the schematic we'll find that out. So we're either back to some weird dirt in here of some sort, or another I need a new theory. The rubbing plate theory didn't seem to work very well. And we're not getting any stations here. There's like 3 versions of how this. There's that one. Once again, the ticking is not the radio. I think it's a plate scraping. As soon as this capacitor is opened all the way, the sound disappears. So that's when the plates disengage. I think there's a scraping plate here. What's that? Yeah. When I said there's DC there, that may be true too, and it may exacerbate the static. But I don't think you need any DC to get this kind of effect. Let's take a look at these plates. I can see they've been bent by the factory. Let's take a look. Okay, let's see what we can see. First, little explanation. What's going on here? You see, I'm trying to use a metal thing. Just use a wooden thing. Looking around here. Okay. So you see the split right here, and then there's another split up here, and the split. And this is so that these sections of the plate can be bent without bending the entire plate. And the idea is this is a form of alignment, and you're trying to make the radio match the dial face exactly. Oh my gosh, you can see it right there. You can see it. I can see it right there. Wait, what exactly? No, I'm not looking at it right. That just shows you how much one of these plates has been bent right in here. Yeah, I'm seeing it wrong. So now we need to look very carefully through here to see if there's any contacts. And I think I'm going to improve the lighting situation here a little bit. Okay, didn't improve things very much, but so I'm looking. It seemed to me when you open this capacitor up, the last little bit, the problem goes away entirely. And that would suggest really a plate dragging the entire distance. I don't see how that's happening here. if that scared you, scared the bejesus out of me. Holy smokes. Sweat came out on me. Oh, look at that plate. Hey. Hey, what's going on there? Do you know which one I'm talking? I'm talking about this one. This one's also bent out quite a ways here, but there's no splits in this plate. So it's not sectionalized. I'm not sure if that's because they really didn't expect anybody to try any plate tuning with the oscillator side of this. All the tuning would occur over here. But this certainly looks like it's bent out. And it looks like it's in contact down at the bottom there. Let's just look. How much closer can I get here? Wait a minute, I shouldn't be moving the camera. Sometimes it's better to move the work around than the camera. Just down a little bit. Okay, woo, almost got it there. That is close. I don't think it's in contact there. No, we're almost open. Well, wow, it's close. Oh, this thing's really, it's really got a weird shape to it. If it's making contact, it would cause a short. Yeah, that's another thing I can look for. That's actually more sensible. Now, there was a suggestion somebody sent me that the capacitor was loose in here. I didn't felt anything that suggests it's loose. And there's no tightening screw on the back here. There's nothing to tighten. So I don't know about that. Okay, now I've moved my camera all over the place. So I'm gonna bend this. Well, let's try the short. Let's try the shorts thing. Yeah, let's try that, because kind of just thinking up these ideas here as I go. Okay, so if we want to look for shorts, it's going to be from the chassis to the stators. So by connecting here, I'm really connecting to these plates here. Because we need to have this visual location. Go on right here, like that. Open circuit, no surprise. Right at the end there. Often the alignment instructions have you do alignment things with the capacitor not quite all the way closed, and I think this is why. Also open, same thing too. I think these things get a little wild right at the end. This one gets wild. Something is definitely shorting out there. Just before the end. But that's not going to be our problem. Let's try the other one. Oh. Exactly the same behavior here, but that's not the problem. The problem is scratching this all the way through here. So I got this set up to 60 million ohms, which sounds crazy to me to begin with. What am I reading here? got my finger on my left finger of my left hand on the chassis. That really shouldn't matter. We're getting a 0. Okay, so you expect this to be open circuit. So if it says overload, it's just telling you it's beyond the range. I had it at 60K there. I'm going to clip this on. I've never sat and fooled around with an ohm meter on a capacitor like this, so I'm really not sure how to interpret this. So we'll start again with this one, the tuning capacitor. Charging up something somewhere. Certainly does seem like wonky behavior when I do this. Whatever's causing these numbers, you would think it would be stable. It should be stable. Turning this shouldn't make them jump around. I don't know what to make of this. Let's try the other capacitor. No experience with doing this kind of thing because it's kind of weird. So this one's fairly consistent. That'd be 20K, 20,000 ohms. Except when you get right down here where the mechanical short takes place, which is turned up a little bit, then you get it right around at 20 ohms, consistent. Not so much on this side. Something weird about how this meter reads resistance. That a capacitor like this would cause something like this. Experimenting is required. I have to admit, I feel a little stupid doing this, but I got another dead radio here. Oh, she's back. We will hook this up the same way. Chassis. Give me a good chassis connection. Here we are. Look, did I do this? Stick shift on a radio. Okay, I'm going to hook this up now first to the... Yeah, I don't think I did this. So, what do you want? You want to go outside now, right? Checked out the garage. Nothing there. Let's just complete this test. I'm just going to complete... Can you hang on? I'm just going to complete this test here. You know, and then I'll go. 60,000 ohms. Did I hook the whole thing up? Let's check. If I did, then this will cause a 0. If I do this. No, something wrong. Something wrong here. It's clipped. Didn't really clip. How about that? There's a 0. Okay, now we're cooking. You can't imagine this is going to do anything other than show you open circuit. Now this is out, this is not wired into anything, so it's completely in the open. I do feel kind of dumb doing this, but you know, for the sake of knowing. Okay, that would stand up in a court of law, I'm pretty sure. You cannot, you should not expect any kind of reading on a meter like this when testing across a capacitor. Oh my God, I feel like I'm 2 years old again. Okay. Okay, my patient cat. Now what do you want? You want to go outside? Is that right? She heard a little sound there. She's just on high alert for mice, and I know why. Okay, so I'm gonna have to let her out of the house. It's a good idea, because then we won't hear from her again. Shh! Don't let her know. Okay, while I was drinking a little coffee, I got an idea here, and that is, if the capacitor, I'm still not sure that the capacitor is a problem itself. If the capacitor is the problem, then hooking up a ohm meter and watching for either a short to develop or an open circuit to develop is going to tell me a lot of what's going on in here. So I'm going to hook this back up. Okay, one onto the, get on the frame here. The other one will start with this side. Put it like that. Yeah, open circuit or a short. Now, what if it's in the middle, for crying out loud? So I'm watching now to see if any zeros occur here at any time. Is there a zero there? Oh, now, if I remember right, this side was consistent. Pretty consistent. Yeah. Let's do the other side. Does it go open or does it go short? Or am I just going to be... If you listen very carefully, you might hear my stomach. Well, it's not going open, it's not going short either. That's the coffee speaking through my stomach. I'm trying to turn this slowly because I noticed there were points where the radio seemed to come to life. Wasn't it at the high end? At the high end it did that. So we go right up to the high end. So there's something wrong with this test. You know, the thing is in the circuit, so the capacitor is in the circuit, so we're not just reading the capacitor here. Maybe what I got to do, oh, it's awkward. So disconnect the lead wire onto here and retest. Or is it all just nonsense what I'm doing? Oh yeah, how did that get, that's open. What did I do? Did I do something? Yes, I did. I did do something. I did this. $300. How do you get 300? Maybe there's another point at which as I turn it, this reading goes down and then comes back up to this kind of number. See? Depends where you are. I don't get it. I don't get it. I don't get it at all. I'm going to have to cut that wire. Now maybe I can cut the other end of the same wire. Maybe it's up somewhere. I think it goes, I think it's going through up to this coil up here. It's still charging something up. Okay, I'm going to take a closer look down there. That's what I want to do. And I'm looking for is that one wire down there connected to that terminal, or more than one wire? Hey, the solder looks cracked, doesn't it? It's probably just a line of some rosin on the surface. It's probably not cracked. Grab my stick here. Oh, my stomach is just going wild. Yeah, I think that's just some... I don't think that's a crack. Yeah, it doesn't flex at all. So there's, looks like there's two wires. Looks like this one, and then another one. You can just kind of take it off this way. That's not going to help at all. Oh my, look at that coil. Looking pretty rough down there. I don't really know what I'm seeing for sure. Huh. It looks pretty terrible, actually. What has happened to it? It may just be... I don't know. It may just be, I don't know. Switch here. So when I'm turning this, what else could I be flexing in the radio that would cause the kind of effects we're seeing? I don't know. Nothing. It's got to be this. Maybe it's just a really, really terrible arrangement here. And now there are cases where the shaft here can be shifted left or right. I've had one radio where you could see the plates were all shifted one way, and I was able to tighten the screw back here, but there's no screw on this one. Is that a cap? I don't think so. And it's not loose. Anyway, it's not loose. It's just a really terrible contact with those rolling balls. And why wouldn't this do the trick? And grounding that center shaft. Oh my gosh. There's just no easy way forward here without kind of digging the hole deeper and deeper. Whatever's happening, I got to figure out, because there's no going forward. The radio worked very briefly there and just was gone after that. What else could it possibly be? It has to be this capacitor. And even with it wide open, there's some other kind of short in here. What other kind of short can happen? I think I've got to disconnect the wires from it over there and test this section. There's a short. There's a short right there. that says something. Some kind of plate short in here. Okay, back to the camera. Let's look again. Okay, there's a look at how the camera's aimed right at the capacitor. Okay, starting on the left side. They don't seem to be dead centered here. They look like pairs of plates because something is not quite centered. But I don't see any contacts at all. What is that? In amongst the plates. Does that look like filings? The plates that are right in the center, the ones I'm looking dead on right now, they look like there's metal in there. Really? Ooh. Wow, is that just dust? Wow, maybe there's see a lot less here, a little out of focus. Not really a lot less. What is all that? Funny looking stuff there. Could those be crystals forming on the surface of the plates? It doesn't quite look like dust. Can I get even closer with this? I would need really a microscope to get in closer. Let me just see if I got this focused all the way now. Not quite. A little more to go. Okay, now we're getting really close here. Wow, it's pretty suspicious looking stuff. Like, it's shiny. It just doesn't quite look like ordinary dust. And they all seem to be like standing up, as if a crystal is growing off the surface. So I'm going to try to clean this. How am I going to do that? I don't know. Paper slid over. I don't know. I'm going to do something. We'll see if that helps. I'll attend to cleaning it. Okay, here's what I'm trying to do. I tried this string. It's too thin. I've got some thicker string here. I'm just going to kind of work it through each set of plates. That's pretty good pressure in there. I think if anything's going to clean it, it's going to be this. Or am I just sort of sharing the contamination between plates here? Never done anything like this. Well, I shouldn't say that. I've certainly brushed with a brush with bristles. Certainly blown air through it. I don't think those would be good solutions. Which one did I just do? Anybody see? Now, is it possible for crystals to grow? Yeah, I think it's possible. What are these plates made of? It could be made of steel or aluminum. If they're made of steel, then I think they would have to be coated because the steel would rust unless they were stainless steel. Somehow, I don't know. So then these are coated steel plates. The coating, which would be another metal, you know, typically you put zinc on steel, but this could be some other kind of alloy or material. It can't be steel or this stuff like bare steel. This would all be rusty, I'm sure. It can't just be bare steel. Could be some sort of stainless steel. So this is picking up a gray color. Now I would think, I've always thought, you know, a little bit of dust and dirt in these things is just not going to do anything. But this wouldn't be ordinary dust or dirt. And most of the corrosion products, as I understand it, they're not conductive. So luckily, copper oxide is conductive. Lucky us. And many of the coatings that develop on metals, the rusts, the patinas and stuff like that, they are not conductive. I can't do much about these bottom plates. Well, let's see if that made some kind of difference. I would expect some kind of performance difference if this is getting anywhere at all. I suspect with the perfectly good capacitor you get a reading of whatever was coming up to 350 ohms or whatever it is based on external circuitry. And I'm guessing that's what we're going to get here. Well, I don't know. Let us take a quick look and see if it looks any different. I'm just going to hold this here. Looks nice and clean in there now. Will that have helped? Okay, put down your money on this one. I'd only roll like a dime on this. Okay, here we go. Let's see if I lose my dime. Everything's okay. Good. Now I will patiently wait for this to warm up. And volume is down. Turn up a wee bit. I can't turn the volume right down. Okay. It's quite a different. Let's plunge it through. I heard a station briefly up here. I'm going to give the other side the treatment here. Do this without operating. You know, I'm liable to get a shock here by sticking my fingers in the radio. So let's not do that. So I think that made a difference. Didn't seem to be complete though. And of course they don't have the stator plates that how would you clean them mechanically like this? You need something to get in there. I guess it's, I didn't really check, but it's safe to assume that whatever happened to these plates happened to these ones too. And if the oscillator is way off, if it's way off frequency or if it's not even operating, you can still hear stuff in these radios. Just tuning it won't make much difference what you hear. Okay, hey, you know what I'm doing? I'm flossing the radio. Okay, back on again. Floss your radio once a year. I think I'm onto it. Now, why would the stator plates be any different? They probably aren't. Let's have a look and see what we can see in the stator plates. Same kind of stuff, I think. One of the things I have for doing dusting is I have a feather. I might be able to stick it up in here if I can find it. Oh, those plates are close. Is that right? Is that right? No. I don't know what I'm seeing in there, some kind of reflection or something. Just the light and shadows. But it looks like, yeah, it has the same kind of dirt in there. Well, you can look right on the outside here. You really see the fur. Yeah, those really look like crystals to me. Can you dissolve them? Can there something you can throw in there that would dissolve it? Ooh, I'm not sure about that. We don't really know what these crystals are. If they are crystals. Even just water might do it. But I don't think I want to spray water all over this. Okay. Well, I think I've got the right diagnosis here. It seems to make sense all around. So somehow I've got to clean those plates up to the point where there's none of this action anymore. That's the challenge. Coffee is waiting. Well, I've tried the brushes here, but none of them are going up far enough. But look, I have my big feather here. And this will go in. So I'm going to feather clean these guys. At least I think that's what I'm doing. What kind of feather is this? Big feather, right? From a big bird. Just found this on my property one day. My neighbor raises chickens. We're allowed to raise chickens in Aurelia. I think they license a dozen families or so to do it. And my neighbor is one of them. And so they have a few too many chickens right now. I think they're only limited to 4, and I think they've got about 8. For innocent reasons, they've ended up with 8. And so those chickens are out on my property every day. We get along with our neighbor really well, so it doesn't matter. They're scratching around in our gardens and stuff, and our cat stays clear of them. But lots of people walk by on our street. Our street is a nice street for walking on because there's no traffic. And people go by, and these chickens are running around on our property. I think they think we're raising the chickens. It's probably a cheap thrill for the children. They're going by. Uh-oh. Don't grab it. Somebody grabbed it there. Chickens eat rodents. So if you're a mouse or something, you don't want to have a chicken around. Okay, let's see what that does in there. There's really no reason to do these more. A feather, who would have thought I'd have a feather in my shop as a tool? Where I actually use it is on the back of glass plates, dial plates, and you can't get access to them, or for whatever reason you can't get in there. I can take that feather and just kind of sweep dust at the back. It works pretty good for that. Okay, we are ready to start again. Yes, we are. Here we go. What will happen this time? A lot of videos now, people cut the fraction of a second in the hesitations of their words when they're talking. Not me. Something's going to take time, we're going to wait for it. Here we go. Well, it's a lot better. Not good enough though. I put a lot of liquid in here, like alcohol, and then do this thing. That might have an interesting effect. Let me get my friend alcohol out here. Yeah, no, I don't mean that. I drink very little alcohol. Just some beer. Maybe 2 cases a year. We want to put a fair bit in there. I'll use a brush here. In there. You can do this with it operating too, because it's just alcohol. What can it do? Okay, the radio went quiet. What happened? Let's put lots of alcohol in there. Now, alcohol is going to dissolve if that's a corrosion product in there? No, alcohol is not going to do anything. Yeah, I did say something about alcohol not having any bad effect, didn't I? Look at, the radio's gone dead. What happened now? It hasn't gone dead, it's working better. Not picking a thing up though. We're getting there, except where'd all the radio stations go? Some strange stuff going on here. Eh? So the alcohol may have picked up some of the metal. I'm assuming it's metal. Maybe it's not metal, and now it's floating around in alcohol on the surface of the plates. Just making all that up. Well, it's quite different, isn't it? In that it never works now. But I certainly don't hear the scraping. Where'd the radio go? Ooh. I did not get any alcohol down the back area there. Maybe this will bring it back. So there's an AVC effect here. When the radio makes some kind of, something happens here, it's causing the AVC to quell the radio. It takes a moment for it to come back, like that. See? It takes a moment to come back. I didn't turn it far enough. I don't know. Why no stations now? My powerful imagination tells me there's a station right here. Something very odd going on. Well, we've gone from one odd behavior to another now. I guess, you know, the more and more these plates go together, the higher and higher the likelihood of the problem showing up. It's really consistent. No. Just wear out the problem. Yeah, AVC. What's happening? So I'm more interested in whether the capacitor is clean now than in the way the radio's performing. We can deal with the performance next. But it does seem to be way better. You know, if I missed one of these plates, watch your finger. I should have had some alcohol on the string. Just gets stranger and stranger. They put a support here for these plates, but there's no support for these ones. Wonder why. So maybe that's, maybe there is a rubbing plate at this point. We can. Okay, enough video of this. This can go on for a long time. So what I'm going to do is I'm going to use my SDR radio, which is sitting right here. And this is the antenna for the radio. This Just clip lead in a loop. I'm going to put it near here, and we're going to look for the local oscillator on the SDR display, which I will now flip to. Okay, so here's the SDR. Now I'm going to put my hand on that coil. And can you see any difference? Very, very little difference. Okay, but there is something happening there. What if I touch the... there, that's my hand on the antenna lead. Okay, so we're going to put the coil up near the radio. It's pretty close already. And there's just no sign of a local oscillator here. So I'm going to tune the radio around and see if something pops up. So the local oscillator would be somewhere around the 1700 mark. That's the closed. Opening the capacitor now. There's no sign of the local oscillator. That's why we're not hearing any signals. Why no local oscillator? So it kind of solved the capacitor, except whoops, still doing a little bit up towards the one end, but at least 3/4 of the capacitor travel seems to be open. Now, what's the radio hearing? If there's no local oscillator, it's hearing signals around 455, I believe. That will still travel through the radio. So there's some noise. There's noise everywhere. Some noise, and that's what we're hearing, I think. No local oscillator. Well, no local oscillator. Sounds like something to work on tomorrow. A few times the radio has come on and started working. The oscillator has probably popped in and started oscillating, but now it's not oscillating now that I did all this cleanup. We seem to have stepping forward and backwards at the same time. Okay, but I'm going to leave that for tomorrow. Tomorrow will be an investigation as to why the local oscillator is not oscillating, and we'll just carry on from there. Thanks a lot for watching.